All right. I don't know if anybody's going to come in live, but I put up my Google Classroom in effort to anybody who wants to do my lessons worldwide. The class code asepxwg. I'll put it in the comments again. But I wanted to go over my lesson. So let's see here. Oh, all right. So anyway, the lab that I posted in my Google Classroom is the first one. It's one that I put in CPalm, which is a website where all of the compository of Florida lessons. It was published by CPalm, my lesson. It's an insulator lab, so it's a lab that teaches kids about why. Oh, I forgot my insulators. Hold on. It's a lab that teaches kids why we should be doing, or how we make an insulator, what is an insulator, and things like that. Okay, so let's first off start with what is an insulator. Do you guys know what an insulator is? Have you ever heard that term before? Do you know anything that is an insulator? And so what an insulator is something that keeps an insulator keeps the outside environment from affecting the inside environment. So it's not something that keeps something hot or cold, which you might think, but it's something that keeps the outside environment from affecting the inside environment. A thermos, refrigerator, those are really good insulators, and that we're going to be discussing some things about insulators here today. So hold on, let me go get my materials. Hold on one moment. All right. So I just so you know, still at Target, these Just Waters are half off, so 50 cents. So I don't know if you're looking for a good. They're in the Target Cafe, by the way. I don't work for Target. I'm just letting you know it's a good deal. Anyway, so to understand insulators, you got to understand what we're insulating from. So in my lab, there's a document that shows you open, closed, and isolated systems. So we have to start with that, right? So this bottle, unopened or opened, you see the top is not on it. This bottle of water is opened. It's an open system, okay? Because what can come into here, energy and matter can go in and out. So matter is the water molecules can evaporate out, or viruses or whatever can go in. So matter can go in and out, and then energy as well. The heat energy can leave, and the heat energy can return, okay? Now, the next one is a closed system. When the bottle has a top, now matter cannot enter or leave. So water can't evaporate out, and nothing, dirt, particles, viruses, whatever, can't enter in. So now we have a closed system. However, energy can still come in and out. So, for example, heat can get into the bottle because it's just going to heat the outside of the bottle, and the inside is going to heat up eventually. And the inside of the bottle, so that's what makes it a closed system. So matter cannot leave or enter, but energy can leave and enter. So, or the inside can warm up, and the cool energy can leave the bottle. So, and then this isn't the right way to think of an insulator, but I have a plastic bag. I have my bottle. Let's pretend this plastic bag really could insulate some stuff. So I'm going to put it in here. Let's just pretend it can. So now what we have is an isolated system. And what that means is matter can't enter or leave, and energy, for the most part, can't enter or leave. Let me ask you this. Do you think there's such thing as a 100% isolated system? Can you even your thermos, is it 100% isolated, or your refrigerator, if you turn it off, would it eventually warm up? Yes, it will. So we're trying as scientists to make a system as isolated as possible, right? So when you do that, you're making an insulator, right? An insulator keeps as much heat out as it can, or it keeps as much heat inside as it can, depending, right? If you wear a jacket, that's an insulator. You guys can come up with insulator examples, I'm sure, all the time. So what I did is my lab that is in my Google Classroom. Again, the code is, let's see, what was that? asepxwg. Goes into a way to determine, it helps you build your own insulator. I'm going to make a few tweaks to it because some of the materials you need are a little difficult to get possibly, and I want to make elementary version as well to it. So I'm going to add more modifications so students who are just learning about heat and matter in elementary school can still do this and learn something from it, because it might be a little more difficult than my lab might be a little more difficult as it is. When you're in my lesson, you can definitely email me any questions, comments. Please do the lesson. If you do it and submit the lab, I will look over it, because learning isn't just students going and learning there's all these people passing stuff around to learn, which is great, but you need feedback too. So if you join my classroom and you submit the work, I will provide feedback. So just make sure if anybody is interested, I'm going to be posting more lessons, most lessons with limited materials, but keep in mind, this isn't just science. Science is the integration of math and language arts, and then you can put history within science. So every science lesson includes all different subjects at all times. It doesn't look like anybody is having any questions. If you join my lab join my Google Classroom, you want to look at the lab, that'd be perfect. I'd love your feedback. I'm going to add more stuff today. My kid's napping and my other kid's watching his tablet. Anyway, thank you very much.